Again, my name is Daryl Matzke. I'm with Raymaker and Associates. We're an engineering firm located in Sauk City, Wisconsin. We do aquatics design, where we do water park design. But one of the things about our firm is that we're a multidiscipline firm. We do not just do water parks. We have an MEP staff. We have structural engineers, geotechnical engineers, civil engineers, and architects on staff. What this allows us to do is have a holistic, have a holistic approach to project development and how to pull the information together and use it and monitor it instead of just looking at things from the pool only. You know, how does it tie in with the building? Just a quick summary of the discussion this morning. I'm going to try to focus on this discussion in regards to what you have for existing facilities. If you have an existing water park, what you can do to it to start reducing energy consumption. The PowerPoint that I put together here, I actually put it together from the design side of things, so it kind of overlaps here. You know. Good design means less changes in the future. Or the other way of looking at it is, as technology evolves, what changes can you make? Items that we're going to be looking at is just overall it's the cost considerations, balancing out the cost of construction costs versus higher efficiency or greener building construction materials. Just taking a look at that. Typical water park energy use, where's your energy being used? Well, we know it's heat and electrical. We'll go into that a little bit. How can we take advantage of the wasted heat? Are there, on your property, are you wasting heat, cooling in one area when you need heat in a different area? How to take advantage of that? That ties into heat in the pool water. And then really going on to the air handling. If you're looking at an indoor water park, indoor natatorium, that's a big ticket item on there. Now, of course, the outdoor, we don't have the air handling. I understand that, but these items carry over across indoor or outdoor. It's just doing a broad stroke feel for it, what can be done in a water park. With that, it goes on to pump electrical usage, how we can work with that, and lighting. Construction cost considerations. Really, it comes down to the initial budget. Feasibility study says to do a project of this nature. The business plan says to do it. But you need to make a decision on where you're going to spend your money in construction. And oftentimes you look at it and say, what do I have to cut to make the budget, or can I incorporate the green technology in there? You got to balance that out then with the operation costs of it. If you're going to be taking a construction loan, you got to pay the loan back. Therefore, you need to do the operational cost analysis and say, okay, I have a water park of X size. It's going to have this number of pumps because it has this type of features. Maybe I have features that are pump intensive. Put that into a spreadsheet, or have your engineering consultant put that into a spreadsheet and show what the operational costs are going to be, so you can look at it and say, how's that going to go in for your revenue generation to pay back the loan on it? It's fine, just general business aspects, but it's going to make an impact when you do that initial construction. Where are you spending your money on it? Now, one of the things that's come back or come around in the last few years is working with the utilities, and the utilities offering grants. They're looking at it and saying, it's to our benefit if our electrical customers put in higher efficiency motors or a VFD or some of the other items in here that can reduce energy consumption. And if we can offer a grant to help pay for the difference from the normal standard efficiency to the premium efficiency with a payback period on that grant, then there's lots of programs that are evolving that way. Like I said, it's coming back to the payback period. Where is it best to invest your money? And one of the ways to do it is actually doing like a present worth analysis. You know, just making sure what makes sense for spending your money on it and what's going to give you greatest return. But it really comes down to construction costs. Can you afford it up front, or are you going to have to do it later as a rehab? So in the water park, I mean, it's pretty much understand what the energy use is. It's the pool water heat loss. That's evaporation, spraying water, surface area. It's the pumps, the filtration pumps, 24/7 throughout the whole season, or if you're indoor, throughout the whole year. It's the feature pumps. Do you run your feature pumps all day long, all night long? Can you shut them down? Do you need all the features running? With the indoor water parks, it's the air handling equipment. You're moving lots of air, and you're heating that air. Again, it's a boatload of energy you're spending on it. And then looking at lighting. Those fundamentals on where the energy is used. With water parks, especially with indoor water parks, rarely are they standalone. Yes, there's a few in the country that have done standalone indoor water parks. Outdoor water parks, oftentimes they're standalone. But indoor water parks tied in with a hotel, arcades, restaurants, convention center, those are all heat generating. I don't know, I like cool weather. I like cool temperatures. I sleep better at night. My wife needs a quilt, but I go turn the thermostat down when I get to the hotel. First thing I do is go in the room and knock the air conditioning down. Well, that's just dumping heat out the window if you're using PTAC units. If you go into a 2 or 4 pipe system and get a water heat source loop running around, you can take that heat that's being dumped out of the hotel and put it into the water park. In the past, what had been thought is, it was individual separate buildings. The project was approached. The architect came up and said, I'm doing the hotel portion, and they would work on the MEP for that. And then the water park is so much different than a hotel. Let's have a whole different MEP consultant do that. And it was like doing multiple designs and not taking advantage of any sharing of the loads. And, well, it's evolved over the past 10 years to we're sharing the loads. So the heat opportunities, like I mentioned, the arcade, the kitchens, laundry, hotel rooms. The hotels are in the cooling mode, and you reject the heat to the outside. How can we use it in the water park? So pool water, people like warm water, 85 degrees, 84 degree pool water, hot tubs, 100, 104 degrees. The water's heated throughout the year. So it's a constant cost that you have on there. The water loses heat by spraying. Or, it'll lose heat just by the surface water and just evaporative cooling there. But then when you take it and spray it, or when you take it down a flume and spread it in a small sheet, or you take it in a bucket and just atomize it, you get so much evaporative cooling on it. So what you're doing is humidity in the air, but the evaporative cooling is dropping the temperature of the water. You need to add that heat back into it. Other additional ways that they're losing heat is with the backwashing of the filters. What volume of water are you dumping down the drain? When you're dumping water down the drain, you're dumping heat and chemicals. So can we reduce the backwashing on it? Evaporation, I talked about the spraying water, but can we go on to using pool covers? That's a method. I'll get into that a little bit later here. Just in essence, what can we do to reduce that evaporation? One of the things that working around the country has provided an opportunity is just the different regions. And you got the dry Southwest, you got the very hot and humid Southeast. You got the northern climates, colder, that is actually reducing the evaporation by controlling the humidity in the building. Relative humidity in a water park where people find it most comfortable is between 40 and 60%. In upper Midwest, we're able to just use the outside air and not do any dehumidification or humidification. On projects that we've done in the Southwest, we did an analysis, and we were coming back and saying that, it's so dry here that we're going to be evaporating water from the pools. Instead of taking the water from the pools, how about adding humidity to the air? In other words, adjusting the vapor pressure in the air. If you increase the vapor pressure in the air, the water stays in the pool. If water stays in the pool, it's not doing evaporative cooling on the pool. You're keeping your heat in the pool. It's just a different way of thinking about it. It wasn't the norm. Most people think of pool areas dehumidifying, especially if you think of the small hotels. They all have dehumidification loops on it, and on the water parks, we were finding not having to do that. One of the things that was interesting is going into water parks, existing operating ones, and just the maintenance not recognizing. You think it's fundamental, but how much energy is being used by leaving the feature pumps on, and then how much evaporation is being used with that. Turn the feature pumps off when the park is closed. Turn the feature pumps off when you're reduced in the amount of patrons. Figure out how to balance it out. I mean, if you have 4 slides, but it's a Tuesday morning in October, why have all 4 slides operating? Maybe you stagger them, 30 minutes with one set of slides on, 30 minutes with 2 others on, so you're not running 4 slides and just a couple families using it. Pool covers. You think of, when I initially thought of pool covers, I was immediately came to mind thinking rectangle pool in an auditorium. And no, there's ways of doing pool covers for irregular shaped pools. We just did one in Albuquerque. It's a wading pool, has features in it. The cover doesn't cover it perfectly. There's some areas that are uncovered, but we have about 90% of that pool area covered. And we were able to do it with a roller cover on it. And it's going to reduce evaporative cooling on it. The pool covers really keep the water in the pool. The bottom picture there is it's a picture of a regenerative type filter as opposed to high rate sand. High rate sand is the most common filter used, but with high rate sand you have 3 to 5 minutes of backwash at 15 to 20 gallons per minute per square foot. It's a boatload of water going down the drain. Regenerative type filters, about 10% of the total backwash that high rate sand uses. Significant reduction in it, and it helps not only, again, heat, water, chemicals, and then a few places we have worked where we have downstream lift stations that don't have the capacity to handle a backwash rate of that size, and doing the regenerative filter, reduced backwash, we were able to hold that without putting a 10 or 15,000 gallon storage tank out below grade. Just general overall thoughts. Regenerative filters can be added after the fact. I mean, if you have an existing water park and your sand filters, they have 5, 10, 15 years age on them. I mean, it just depends where your water park is in its life. You can replace the filters, and it may make sense. In fact, with the regenerative filters, a project we're currently doing in Vermont, Efficiency Vermont is a program that electric utility has, and they are chipping in money for the regenerative filter. And the filter it's not like there's any wires plugged into it to use electricity. It's not a motor. It doesn't use heat, but when we presented to them the effect on the water savings on it, went through the calculations, and Efficiency Vermont came back and said, hey, it works. It meets our intent. It wasn't what they originally thought when the program was put together, but in the end, it said it achieves the same goal. Solar collectors, heat and pool water, or heating water in general with solar panels. The technology is starting to get there. Last year, a firm came to our office that was developing a new set of solar panels. Typically you just always envision the flat ones on it, but they can't rotate or very expensive on it. They working along the lines of doing a parabolic collector so that the sun hits it and the reflectors focused the energy into a concentrated point. Really, we're able to gather the energy much more efficiently in that. They haven't come out on a big installation that I'm aware of yet, but what it was neat is 5 years ago it was kind of written off that solar wasn't there for it. And last year to have this company come in and say someone's working on it. I suspect 5 years from now solar panels will be very common for new pool construction, and what you need to look at for existing. Can it be put on the flat roof of an existing indoor water park? See how it works. One of the things that has come along strong is the use of water source heat pumps. A little bit complicated name, but the essence of it is, again, taking heat from one area and putting it into the other. Back to one of the first slides there, saying your arcade is generating heat and your pool needs it. How are you going to get it there? Well, the equipment that's used, it's referred to as a water source heat pump. They can be added. They can be installed after the fact. We're working on a project right now where it was constructed 4 or 5 years ago. That wasn't the water source heat pump wasn't in the initial budget for it, but the HVAC system that was used there was conducive to adding some additional water source heat pumps in it, and we went and reviewed the operations and are helping them determine that you do have enough heat that's being generated off of this room that is being wasted away. Let's collect it and take it over to the pool water. It's something like I said, can be added to existing facilities, but it's obviously it's best if it's incorporated in the original design. Where it works best in the original design is if you have a centralized boiler plant. That you have a centralized boiler that's serving the hotel, convention center, pools. Maybe you have multiple boilers, so one goes down, you're not totally shut down with it. So you have multiple boilers. You use heat exchanges as opposed to gas-fired, individual gas-fired pool heaters. Use heat exchangers to heat the pool water, and you can tie that in with the air handling unit. Right now we have a project. In the past, a lot of our projects we had gas-fired air handling units. This particular project, we went with a central boiler plant, and we're using hot water loop to heat the pools, heat the buildings, and also heat the air handling unit for the water park. A recent project I worked on, and I don't know if this is going to get into the private sector or only the largest resorts, but I just completed a project where a new high school constructed. So I think they might have 1,500 students there, so it's a good size high school. And for the campus, they put a groundwater source heat pump. So they were using geothermal energy to heat the buildings, and the heat pump was running a water loop throughout the whole campus. And again, down in the classrooms, they're generating heat. In the pool, they need heat, and they're just transferring heat around it. And then they're using the groundwater as a heat sink, or to use to heat the buildings in the wintertime. These next couple of slides are in the packet here, that you can review them yourself if you really want to get into how a water source heat pump works. But just fundamentally, it works like a refrigerator. A refrigerator is a simplified version of it. You're taking heat, transferring it out from one area and moving it to another. Again, just talking how to transfer one heat from the other. The upper picture, that's just heat just being wasted away. How can we capture it? And then you get a few places that decide they really want a nice pool with a waterfall effect, and let's keep it running all winter long. It wasn't the most energy efficient idea, but it certainly created the setting they wanted. They wanted that setting, and we needed to work with the client to determine, okay, if you want to achieve this, how are you going to be to operate it efficiently, and work with the client to figure out, let's capture heat from other places for it. Indoor water parks the air handling units are huge. This particular photo behind the block wall, there's 2 air handling units. Both of them are the size of a good-sized Winnebago. Both of them. I mean, you're talking, semi-truck trailers. That size, they're big. And this particular water park was less than 30. It was 26,000 square feet. And the ductwork on it, 42-inch diameter, 48-inch, are just moving a boatload of air. And the reason we're moving the air so much is it's really working on the air quality and working for the chloramines. If the hotel scenario, the small hotel where you walk in the lobby, they have a pool. I really hate that. It shouldn't have that smell. Air handlers, about 4 to 6 turnovers per hour is what it was shaken out to be. And again, this is evolving. I've been involved myself for 13 years doing this work and seeing how it's working out. Before it was, we were taking 100% fresh air in, and that's taking a sledgehammer approach to it. And the air handling units were that large to get that 100% fresh air in. You have flames to heat the air. Then it evolved into heat exchangers so that the air that was being exhausted was passing through the heat exchanger, capture the heat to put in the incoming air, but it's still 100% fresh air. The project was completed about 1 year ago. We put VFDs on the fans, and we put occupancy sensors. And what we did is monitors people walking in, people walking out, what your water park capacity is, and ramps the fans up and down based on that.
Did you do that through turnstiles or recognition CCTV?
That one was on wristbands, so yep. And other ones, we had another water park set up with the turnstiles. Didn't get to that. Again, it was construction budget that kind of ran out on it, or got to that point where needed to make some decisions on where the money was going to be spent on the construction. All the conduits and all the technology support's is in there to add it at any time. The next step that we're doing on it, and this is on the current project our office has under design in Jay Peak, Vermont, and is recycling some of the air. I mean, that comes back to I mentioned the whole typical hotels where they have dehumidification. One of the standard brands is Dectron. A Dectron unit is just recirculating the air, dehumidifying, and when they dehumidify the air, they're just sending it back into the pool area with a certain percentage of fresh air. Okay. They were chasing their tail with the dehumidification. Certainly on water parks, you chase your tail. You dehumidify this air here. What you're doing is you're reducing the vapor pressure. Well, the vapor pressure, when that reduces, the water that's in the pool says, well, heck, I'm going to come out of the pool and get in the air. It's like you dehumidify the air, and then more water evaporates out of the pool just so you can dehumidify more, so more water evaporates out of the pool. It's really chasing your tail. We're balancing the humidity out with outside air coming in on it, mainly in the in the cold temperatures. Outside air has such a low humidity, but we were still doing the sledgehammer approach with 100%. What we've been doing on our most recent projects is putting the occupancy centers, doing the VFD to reduce the fan speed, and now we're also cycling some air back in. So again, Tuesday morning in October, let's cycle, instead of having 100% fresh air come in, let's have 50% outside air come in as opposed to 100% recirculated around. One of the items that can be added to a water park, if not in the original construction, is the large ceiling fans. What's the benefit of the large ceiling fans? You got a lot of heat sitting up at the ceiling. Move it down and around, circulate it around the building. Move the air around it so you don't have condensation concerns. And the next thing is you're moving the air around so you don't have a chloramine buildup. Again, it's the bad water making bad air. The chloramines are heavy. They hang out in the low area, and that's where the swimmers are. The lowest point is this, pool at chin height, and that. So yes.
And even with the best dead spots.
Absolutely. What we found over the years again is we take the large fans, but also we would take the air. The return back to the unit is drawn from the low because the chloramines are heavy there. But one of the things that people need to understand is, why are you worrying so much, or you're spending a lot of money on the air handling unit because you have the chloramine smell? Work on the water. Improve the water quality, you're going to improve the air quality. And some people lose focus on that, and they I don't know, they don't monitor their water well enough, or they don't have the staff trained up, or you do need to consider enhanced treatment. UV has worked very well. Okay, I mentioned occupancy sensors for fan speed adjustment, outside air adjustment, improve the water quality, the experienced staff. Chemical controllers, please, everybody, put chemical controllers in. Don't rely on staff to do it by just test kits. And liability-wise, chemical controllers really protect you there. UV works very well at helping to enhance that water treatment and breaking down the organics and inorganics and breaking down the chloramines. Improve the water quality, you're going to improve the air quality. Low area returns, you have your exhaust located at the floor. This picture shows, it's actually a rendition that we did for our project in Vermont. We're using an open air building and we have an operable roof on it. And yes, there are some nice summer days in northern Vermont. And yes, yeah, but yes, but they like the open air building design, the structure for the natural lighting, which will come in later on when we're talking about energy reduction and lighting. But we're also going to be able to take some care of some natural ventilation here. We're going to crack the roof open, or on those 3 days that roof will be wide open and they'll be looking up at the mountains. Actually, what you're getting is natural ventilation, but you're also getting a new water park. It's a whole different feel. And then it's certainly a different feel with a glass roof system or a translucent roof system as opposed to the big box style water park, with steel trusses and everything painted white except maybe a mirror on the wall. On to the next topic of how energy is used. It's in the motors. It's the filtration pumps. It's the feature pumps. How do we reduce it? Finally, VFDs are really coming into play. The technology has been there for a long time. It just never seemed to hit the proper price point. The VFDs have hit the proper price point, and then you take the added advantage, again, of those grant programs. They're starting out there. It's really working out nice. So go with the high-efficiency motor. If you can get up to premium efficiency or the next rating up there, again, talk to the utility company. And don't go into the utility company and say, I've already purchased these motors, can you pay for them? You've let the horse out the door by then. Go into the utility company and say, I'm putting these standard efficiency equipment in. I'd really like to do it, but I need help. And see what they come back with. Because if you already go in and do it yourself, they're going to say, I don't need to give you the money to do this. You already purchased it. Well, use some leverage there, not only with this utility company on something for grant writing, but overall, you're going to be a favorite customer of that utility. Work with them early in the project. Proper pump selection. The engineer, the designer should be doing calculations on what the head loss is going to be to pick the correct pump out so you're not deadheading. I will have to say this, though. In the past, because of VFDs not readily being available or not using them because of the cost issues on it, engineers did design conservative. I did it, and I'm not the only one. And the reason is that water slide has to have a certain flow into it. And I'm not going to have too little water out there, because if it needs 800 gallons per minute, that's what you better be putting, not 600 down it. And therefore, you do the calculations. You're saying, I'm sure this is right, but I'm going to be a little bit conservative. And guess what? We have a throttling valve, a butterfly valve on it, deadheaded, just wasting energy out there. With the VFDs, we can add that, turn the RPMs down, and you'll have the electric you use follow the system curve, and then you follow the affinity laws, and you can get up to 30% electrical savings. Now, if you have an existing water park, that's certainly something to go back and look at. How long has your park been around? Where are the valves set? And are you deadheading? If you're deadheading, let's consider putting a VFD in it. Yes?
So why not use a VFD?
Absolutely. Go.
Want to be without a software.
All right. Right. And that, again, it's the utility company is going to support you on that, because they don't want you coming across with that much load on it. Lighting, natural lighting. If it works into the building program, you're going to have some energy lost through the R factor on windows. Understand that, but be smart in your window location. Watch, or you're going to get some solar gains on it. Maybe you need to balance it out from being too much solar gains on it. But end result is if you can get natural lighting. A lot of times we design a water park a clear story up at the roof, up at the peak, so we get some cross lighting coming in, so it's not a big dark shadow up there. And limited amount of windows, but you just really getting a lot of light off of it without just spending a lot of money on additional fixtures on it. Yes. I have not used the Foiltech system. I don't have the details. I can get the details for it, but I have not used it. And the open air system, or when the architect was determining whether open air should be used for the project in Vermont, they also did calculations with Foiltech. And after the program, I can get your name and we can get you in touch with the architect. And he may have some information on how that calced out, looking at conventional construction, open air versus Foiltech, how that all shook out on the project. But in the end, it also had a big effect on what the owner wanted. The owner liked the natural light, the translucent light roof systems. And whether it came out to Foiltech or the open air system, certainly both companies were battling hard to get it. Light fixtures, LED light fixtures are now becoming cost effective. They're very, very energy efficient. And as opposed to the high pressure sodium or metal halide fixtures that were common 10 years ago, they're being taken out, and LEDs are being put in, or fluorescent fixtures are being put in. And again, that can work on existing water parks. Go in there, Wilderness Resort, and I guess Wilderness and Kalahari both did it. They went in and essentially took out virtually all their light fixtures in their existing indoor water parks, and they put, I think both of them put fluorescent high bays in there, but they're very efficient fluorescent bulbs. And that's, again, it's new fixtures have come out, be cost effective on it. Went in there, retrofitted it. Both these water parks, they were 10 years old, and it made sense to go in there, and when you run the calculations.
Is that technology?
Yes, very much so. And so LED pool lighting that's what we're specifying now, as opposed to, the standard pool lights, 500 watts, I think they're sodium. Sorry, I can't recall exactly what the bulb type was, but they're so hot. They run hot, and and the LED lights it's very nice to have them available now. Center picture, just wanted to throw that one in there as along the lines of thematic lighting. Yes, there's codes talking about how much lighting you have at the pool areas, and so we did underwater lighting, we did coping lighting, but up at the ceiling, actually worked with a set designer and put the starlight ceiling up there as opposed to making it a big white room. It turned out really beautiful. That's in Minnesota, Maple Grove Holiday Inn, so it's just outside of the Twin Cities. The other day I was sitting in on these same seminars, and there was a couple items that I heard one that was presented by ADCI, an architectural firm. Also, Wilderness Resort, Joe Schmitz from there had mentioned a couple items that I didn't have slides for, but they mentioned it, and I said, dang, Daryl, you could have had a slide on that. Talk about insulating water slides. Depends what effect you want in regards to, do you want your water slide to be that beacon along the highway where you have a yellow, a bright green, a red, blue slide on it, or can we just insulate it and just all becomes one solid color of the insulation? They haven't got to the point of where I've seen them do multicolors for the insulation. But the insulation is 2 or 3 inches of insulation. We did measurement of heat loss for a couple weeks. I'd picked the coldest nights of the winter, and I went up to Chula Vista Resort in the Dells. I was 0 degrees out. Took the water temperature at the start tub where it was exiting out the building and water temperature where it was coming back in. It was about a degree drop in temperature. Well, you do the math on that and look at the 1,000 gallons per minute that was coming down the slides, and you went, whoa, there's a lot of heat being lost here. They have not insulated their slides. They recognize that heat loss. It's a decision for them to consider. Wilderness Resort, when they put their slides in, they decided that is exactly why all their slides are insulated. They valued the energy more than the eye candy appeal of it. Just 2 different perspectives. But it's one thing insulating slides, that's obvious. But it's another thing, just a simple thing. Again, I went to the Waterparks, and I picked Chula Vista because they had a couple of slides that are essentially 100% outside. So it was really easy to wrap your head around what was happening with it. And turn off the water and kind of let the air stagnate around, and you go down at the plunge pool and just feel the cool air, the draft come in, just because the cold air sinks, and it was just a natural ventilator there that's just heat's being lost and cold air's coming in. All I had to do is take a styrofoam plug one end of the slide, and you no longer have that ventilation loss on it. A simple thing that maintenance staff at the end of the day in the winter, plug the slide, and you're not going to be losing heat through that slide, or certainly not as much as you could feel. Just stand there and it was like a fan. A little bit exaggerated there, but you certainly could feel it. Another item that Joe had mentioned, and it had slipped my mind, but we're doing the same thing up at Jay Peak. We're putting it's a large resort. Their electrical service, they're in the mountains. If the power goes out, it's not going to be coming back on real quick, or may not come back on real quick. So they're putting a generator there, emergency generator. But you can talk to the utilities about using that generator during peak periods to generate electricity that you're actually paying back or giving back to the utility. It's a cogen program on it where the utility may come back and say, when we have a peak, we'd rather pay for the diesel or the propane that needs to be run on that generator than having your load on it. And in fact, it just comes down to a summertime load when there was peak electrical on it, maybe a program that can work out with the utility company. This one's a little bit touchy in regards to how the pool was originally designed regarding the recirculation rate. When our firm designs water park pools, we over-design the filtration because we know it's going to get overloaded, and that's when you have your peak guests in there. And I'm trying to anticipate what's going to happen on that Christmas holiday week when the water park is packed and it's running, though. You have a hot tub there, and it's running at full capacity all day. That water's going to get dirty, and when you have such a peak there, in Wisconsin, they want hot tubs running at maximum 30-minute turnover. We usually design it for 15 to 20-minute turnover because we know there's going to be peak periods, and that's when you don't want that number. You don't want to jeopardize the guests or have them discouraged because your water is of poor quality. So we turn it over that much quicker. Well, again, you're looking at Tuesday morning in October, saying, well, why am I turning the hot tub over at 15 minutes? There's nobody in it, or there's one family. It's a big difference from what you can have at the holiday breaks. Again, you put the VFDs on it. You can cycle the RPMs back and cycle the pump rate from 15 minutes back to 30 minutes. You just reduced your energy consumption significantly on there, but you need to be monitoring this. This isn't something that you're going to do and forget about it, meaning that you don't want Tuesday morning to turn into Friday evening and Saturday and maintenance forgot about it. It's something that one, your staff needs to understand it, but maybe what it is as a pool manager really needs to know the electric utility or the gas utilities and have that meter, those meters actually on a program, spreadsheet monitoring it, and it's a daily look at what's our meter consumption and why are we using so much gas today. And after about 2 years of collection, you're going to start to understand your trend, and you can look at it and say, room occupancy is going to be down for the next 3 days. Let's back the recirc rates down on these pools back to what the code is, as opposed to having the higher turnover rate that we need for when we're full on the weekend. It's again getting to know your systems. Design that's efficient. Don't take an engineer or an MEP engineer that does commercial office buildings and he's going to do your indoor pool area for the first time. It's not going to work real well. Find the qualified engineering firm that has the experience and then tell them your goals, your business plan, what your desires are, and work together with the engineering firm to come up with a solution and then see what you can find on grant programs.